Hi everyone, today we're doing lesson 3.3, characteristic of polynomial functions in factor form. Any polynomial function can be grouped based on their shared common characteristics into family of polynomial functions, which are basically a set of polynomial functions whose equations have the same degree and whose graphs have common characteristics. When we talk about order, we're talking about the degree, which are basically the number that x has as a power. There are several steps to sketching a graph from an equation. What you first have to do is find the y-intercept. Then you have to find the roots, which is basically the x-intercept. Then use the value between the x-intercept to determine if it was a local maximum or minimum. Next, you have to determine the end of the function. And lastly, you can just sketch the graph. Now let's take a look at example 1 from your learning resources. It tells that to find a cubic function with the roots -1, 2, and 3 over 4, with the y-intercept as 10. Well, first we have to find the y-intercept. In order to find it,
we first have to write the original equation out. We have f of x equals to a in bracket x plus 1 in bracket x minus 2 and in bracket 3x minus 4. We are actually already given the x-intercept in this case, and it is 10. We know that at 10, x is equal to 0. So we can plug that into the equation in which f of x equals to 10 and x equals to 0 for all x. That'll give us 10 equals to a in bracket 0 plus 1 times 0 minus 2 times 3 times 0 minus 4. That'll give us a final answer of a equals to -2. In the next step, we have to subtract in the value into the general equation. That will give us f of x equals to -2 in bracket x plus 1 times in bracket x minus 2 times in bracket 3x minus 4. And that will be the final equation. We have already talked about the domain and range in Unit 1, but we have to talk about it here again because when we look at a graph, we have to determine its domain and range. The domain is the set of all real numbers of variable x of a function. The range is the set of all variables y that is resulted according to the x value of the domain as a part of a function. Now let's look at example 2 from your learning resources. From the domain of a function f of x defined by f of x equals to 1, 2, 2, 3, and 3, 4. So we're given 3 points on the graph and we're asked to find the domain. The 3 point actually consists the graph, so the graph is only 3 dots. It's very easy to find the domain because the domain would just be 1, 2, and 3. That would be the value of x in the 3 dots. And the range would just be the value of y of the 3 dots. That would be 2, 3, 4. Now let's look at example 4 from your learning resources. It asks us to graph f of x equals to negative in bracket x plus 3 times in bracket x minus 1 times in bracket x minus 3 to the power of 2. So first of all, we have to find the y-intercept. We know that at the y-axis, x equal to 0. So all we have to do is plug in the 0 equals to x into the original equation and see what we get for f of x when x is equal to 0. In this case, f of 0 equals to 27. So when x is equal to 0, y equals to 27. And that's where the graph intersects with the y-axis. Next, we have to find the root, which are basically the x-intercept. So at the x-axis, we know that y equals to 0, which means that f of x equals to 0. Then we have to plug that into the equation that would give us 0 equals to negative x plus 3 times in bracket x minus 1 times in bracket x minus 3 to the power of 2. That will then give us x equals to 1, 3, and -3. What we have to do now is use the value that we have just determined, that was -3, 1, and 3, and write them in a table.
we want to know where in the graph is it negative and where in the graph does it have a positive y value. We see that when x is less than negative 3, the graph has a negative value. When graph is equal to negative 3, the graph is at 0. When the graph is in between negative 3 and 1, it has a positive value. When the graph is x equals to 1, it's 0. When x is between 1 and 3, the graph is negative. When x is equal to 3, the y equals to 0. When x is less than, it should be bigger than 3, y would be negative.